So this was titled on the track, Lock Up Your Data, but after playing around for a while, I decided I actually liked this title more. Safe data is happy data. The implication being that unsafe data is unhappy data, or data that someone else is happy to have, not necessarily someone that you're happy to have it. The idea in 45 minutes is to give you an idea of how to think about data security rather than giving you a whole bunch of detailed tools that would help you with one aspect of data security but not others. So one of the first questions that I get frequently on IRC when I bring up the issue of data security and web application, database-backed web application security for data is, why should we care? You know, if you're an application developer, actually, how many people here are primarily application developers? This is a fair amount. How many people here are actually DBAs? Sysadmins? Okay, we've got a pretty good mix, but a lot of application developers. So in a lot of cases, it's like, why should we care? And I get this not just from random people in IRC, but also folks, you know, working at Cisco or Yahoo or Microsoft or whatever. And I get a lot of different answers as to why data or database security is not important. A fun one is our network security or firewall or whatever. That'll take care of it. I applied all the patches, so we're secure. How many people think that works? One of my personal favorites is security belongs in the application layer. And that's generally coupled by this other one, which is putting security in the database will slow down development. And of course, my favorite lately is that, of course, nobody can hack my website because we run on Linux. Well, couple hundred, I haven't checked the latest statistics, websites today and web applications actually are hacked. And replaced by various hackers working either casually or commercially. And you would like to think that these were just random personal sites and small companies who didn't know what they're doing. But hacked sites include Microsoft's website, Nokia, government agencies, the UN, political parties. Now, being hacked and having your site and your web application defaced, you can think about it, it's pretty embarrassing. You have downtime, you have to explain it to your customers, you have to explain it to your boss. It's extra embarrassing if you happen to be John Howard. But other than that, you know, okay. So having the website hacked is bad, that sort of thing. But how does this relate to data security, and how is it worth actually spending money on? Well, it's not just your website that gets hacked often when it's hacked, because when somebody hacks a web application or another kind of application, if they are a professional cracker, often they are after data. And if you look through, just go ahead. I just picked these off of Googling, you know, web application hacked, database hacked off of Google. And I was able to pick up hundreds of news items of major places. Not just, you know, small startup online stores, but AT&T, a major online supermarket, and the cost of having your data hacked and stolen is enormous, because not only do you have to deal with the police and all the time and the issue you're hacked, and you know, but in some cases, and this was actually off of the AT&T one, you know, you can see where these are my estimates, but you can see where it could cost you literally millions of dollars to have your database hacked once. And if you have a small company or a startup or something, that can be the end. So taking care of data security is not a matter of a nice to have, it's a matter of we need this to stay in business. So, given that it's important, how do you make your data safe on your database-backed application? Well, one thing I need to explain before I go through the rest of this is that one of the important concepts to understand in terms of making your data and your database safe is that security and control are two different things. A lot of people tend to confuse them, to think that more control equals more security. And it's very important to keep this in mind because the rest of the tools and ideas that I show you are going to be largely what is called control systems. That is, systems for keeping control of who has access to your data. But you only achieve security if control systems are properly used. If control systems are misused, you actually end up less secure. I'll give you a good example of how an abuse of a control system makes you less secure. I think everybody's seen this in some place that they worked. One of the things that a lot of people do, like a lot of first-time sysadmins like to do, is they like to put cracklib in their network on the paranoid level and insist that all users comply with it in terms of choosing passwords. And that's cracklib. It's a control system. And then what happens is that people are forced to choose these really gnarly passwords in order to meet the cannot have part of a dictionary word in it and must have large characters and small characters and numbers and must be at least 11 characters long type thing. They end up with a password they can't remember, which they then write down and stick to their monitor. So that's an example of implementing a control system that results in less security. If you think of your favorite government agencies, you can probably think of lots more examples in the real world of implementation of control systems that actually have led to less security because the control systems were not implemented with a goal in mind. So one of the popular ways of making your data safe, and the way that I see a lot of particularly web applications doing it, is something that we call perimeter-only security. And with perimeter-only security, what you do is that you have a hardened box, like a router, or sometimes your web server is a hardened box. So you have a hardened box that is really locked down. Maybe it's running OpenBSD. It's got all these patches and extra security software, and maybe you've got a Barracuda box and that sort of thing. And that is designed to completely control access to the rest of your systems, which are left open and relatively unsecured, not really controlled, to make it easy to do agile development and whatever. And because after all, because you've got this hardened sort of guard sentry out front, that'll keep anybody from accessing these vulnerable systems. The problem with that approach to security is that it doesn't work. Because if anybody can get through this, or better yet, around it, then they have a free run of whatever's in here. And you don't even necessarily know that they were there. And people say, oh, well, no, of course, we're running open source software, right? So nobody's going to get through that. We've really got it locked down, right? Because after all, there are no exploits in Linux. And like nobody has exploits in a major service like DNS or Apache. And of course, those web interface languages, those are always completely secure. Of course, perimeter-only security appealing to people is not limited to the IT industry. A good example, if you ever have to explain to your boss why perimeter-only security is a bad idea, is this one. Pretty much all of you went through this on your way here, which is, for those of you who can't really see the picture, this is, of course, airport security. I think it's Seattle Airport in this case. Hard to find pictures online of airport security because you're not allowed to take pictures, because somehow they think that makes them more secure, I guess. So you've got airport security. And the problem with the passenger airport security is it is a perimeter-only defense system. And the problem with perimeter-only defense systems is that, again, you only have one layer of security and then people have free reign. I mean, basically, when you're going through this, they x-ray you, they check up on you, they check your ID and your boarding pass and other things. So supposedly they're checking who you are, who you say you are, and that you have a flight in there, and you have legitimate business there, and that you don't have anything on you. And then once you are past the security, you have almost free reign of the whole airport. Anything that you can access without going through one of those employee doors, and I have to tell you that those employee doors are none too secure themselves. And the problem with this is that, well, like a year ago, a researcher actually realized a tremendous flaw in the system, which is that the security guards have no way of validating your boarding pass. And therefore, you can take any piece of paper that looks approximately like a boarding pass, combine it with your own ID or a false ID, and get through the security stuff, and then maybe substitute your... And then, of course, once you're inside the airport, and you're actually boarding a plane, they only ask you for your boarding pass and not for your ID. So it is actually childishly easy to get onto an airplane with false credentials. And so this whole mess, in terms of identifying and tracking who is in the airport and who is getting on airplanes, is actually absolutely useless. Of course, the FBI's response to this was to arrest the researcher and not to change the system. So that's an example of why perimeter-only security does not work, and is a matter of fact often worse than no security at all, because it gives you a false sense of security. So instead of perimeter-only security, what I advocate, and what people who think about security a lot advocate, can be called multi-layer security. That is, if you have anything worth protecting, and if you have a server on the web, you have something worth protecting, because if nothing else, some whereas distributor wants to hack your server to use it as a redistribution point, even if they don't want your customer data. And if you have customer data, then somebody probably wants it. If nothing else, then to spam those customers. Is that every resource in your application stack has to be locked down. Everyone has to, you have to have a security policy and a plan and an appropriate use of control systems and other security tools for every part of your application stack in order to secure your data. And what I'm going to talk about in particular, because this is about databases and database security, is that part of that is your database server. And one of the things is that if you're using something more, sophisticated, more server-like than SQLite or flat files, then you have security tools that actually come with a database server. And you can use those security tools and control systems in order to make your data more secure. So, I was talking about appropriate use of control systems. And in order to decide what is appropriate and what is not appropriate, you have to decide, what am I protecting myself against? Because if you don't know what you're protecting yourself against, you don't know what control systems to use. And the control systems you do use may actually interfere with security instead of abetting it. So when you're looking at a web-based database application, these are your primary four vectors for people unauthorized or illicit use of your data. SQL injection is a popular one because that requires no inside knowledge. And SQL injection, for people who aren't already... Is everyone familiar with SQL injection? Yeah. So SQL injection is a popular one, and that's the one that you hear about all the time. But one of the ones you don't hear about a lot, most people are really embarrassed, is that if you make the mistake of leaving, if your database server is open to the world, then you obviously have the threat of direct connection to the database server as a vector, as a way to get into your data. Also, web server compromise. That is, if there is an exploit on your web server and an attacker can take over your web server, then they can do anything the web server is entitled to do with the database. It's not a matter of SQL injection, it's a matter of whatever rights Apache had in terms of connecting to the database, whatever passwords were stored in an HTML file, or a PHP file, or a Perl PL file, or whatever, are now accessible to the attacker. And how do you protect yourself against that? And the last one, and the one that I find that most people tend to forget about or wishfully not think about at all, is the disgruntled employee, the disgruntled or dishonest employee. This is one of my personal beefs, for example, with PayPal, who, at least in the early years, had quite a number of incidents with employee access to customer financial data, and didn't really do anything about it. It's been a number of years since then. They may have fixed it, but at the time it was the reason for me recommending that nobody use PayPal. And they're hardly the only ones. And actually, I've had, in the case of staff access, I'll tell you about, that's the one where I've actually had a number of customers back when I was consulting, that specifically needed help with security. It was after a staff access incident. And that's actually the most frequent data theft is by staff members or former staff members. So it is a vector that you should be actively thinking about. So for these 4 vectors, I'm actually going to give you 6 different tools. Like I said, 6 different tools, of which 5 of them are control systems, to battle these vectors and make it harder for anybody approaching on these vectors to get data that they are not entitled to get. This is the list so that you can have it later, but we'll be going over these in detail. So the first thing, and the thing that everybody should enable as soon as that they install the database server, is some form of access control. And access control simply says who can connect to the database, and from where. People often forget the from where part. And this is generally accomplished through a user and permissions list. So in the case of PostgreSQL, for example, we have a file called pg.hba.conf. And pg.hba stands for host-based access. And pg.hba.conf has a list of who can connect from where and to what. So which database can I connect to as which user from which networks. And I'll explain this in a little bit more detail. I'll have the example later on. So that's Postgres. And the idea is that you can prevent a lot of kinds of attacks simply by saying that, for example, if your database server, due to its position on the network, has to have both a public and a private network address, don't allow database connections from the public address. Period. And don't allow administrative connections from the outside network. Those sorts of things. You can also do this in MySQL to a somewhat lesser degree. MySQL has this user table, which includes user at host information that can say which user or which host can connect. Doesn't have quite as specific information. You also tell it which database you can connect to. So you can come up with the same sort of scheme in MySQL in terms of who can connect from where. Now, this is actually tied to the second access control method, which is authentication. So the idea behind authentication is you want to not only predetermine who can connect from where, but like Homeland Security is trying and failing to do, you want to make sure that they are who they say they are. And there are a large variety of different authentication methods that you can use, particularly with PostgreSQL, but in combination with your operating system often, in order to make sure that people are who they say they are. So the main sort of authentication methods you look at, and in this case I'm actually talking about Unix systems in particular, because I don't know how to secure a Windows system. I'm not sure it's possible. Somebody who's a Windows expert probably can contradict me on that, but in those terms there's 3 basic sort of, and here I'm using actually the PostgreSQL terminology for these things, but the general idea is that there's actually 3 sort of generic ways of authenticating users on a Linux or BSD system, or Solaris system, that will make sure that they are who they say they are. So one of the popular ones that's used internally for and is particularly good for automated administrative tasks is to use ident. And ident is a system for local Unix connections to your database that says, I just want to determine that the shell user is the same as the database user or is some predetermined mapping. And that's really the only good way to authenticate automated administrative tasks, unless we're going to get into some of this stuff, which can be problematic for stuff that's just running internally to the database server. But definitely, you shouldn't be having... I mean, one of the things that's implied here is that once you've set up your system in production, there shouldn't be any non-authenticated users. No one should be able to simply connect without a password. There's never a good reason for that on a production system. So if you need to connect in a passwordless way, but still authenticate the connection, ident can be a good choice for the automated tasks. You should not be using it for actual database users, because particularly if you enable ident in a network sense where you accept the ident ID of an external server, you have no control that the shell user in that external server is actually who they say they are. So ident is good for internal only, bad for external. Now, the standard way that most users are authenticated in most database apps is to use some form of hashed password. Postgres, we use MD5 by standard. You can use some other hash algorithms, but it's a hashed password. And obviously, username password access is very simple, easy to understand, eminently portable across whatever platforms you want to use. But the problem is that when we get back to our vectors, one of the vectors that I had that happens fairly frequently is web server hijacking. That is, the attacker finds an exploit in Apache or PHP or Perl or Zope or whatever, and they hijack your entire web application. So any files that the web application had access to, the attacker now has access to. And those files include the hash password for the web application user. So suddenly this authentication method does you absolutely no good in terms of that attacker, because they are authenticated. And there are some ways to deal with that. That's the reason why a lot of people, even though this is fairly painful from an administrative and setup point, go to external authentication methodologies, which includes Kerberos, GSS-based systems, LDAP, some other things, where you need a third server to authenticate the incoming user, and that they actually have to authenticate against that server. Now, there's some real drawbacks to this. First of all, this tends to be painful to set up and troubleshoot. From a connection performance standpoint, it tends to slow down new connections a lot because you're bouncing your authentication off of another server. But it does make hijacking, by simply hijacking passwords, a lot harder. Because generally, if you set this up correctly, well, the web application has the right to use the local Kerberos token, for example, to authenticate against the server. That's not necessarily directly accessible to the person who's hijacked the web server. So, so you sort of decide what you're going to do. Now, in that, there's also SSL, which is neither an authentication nor an access control. It's actually, SSL is a connection method. The main reason to use SSL, there's two reasons. Number one, obviously requiring a certificate means that an attacker has to have access to all of the files in your system and not just a few of them, because they need to get access to the certificate file to do an SSL connection. The other advantage of it is that SSL is good for protecting you against man-in-the-middle attacks, where somebody hijacks an existing connection in order to break into the middle of it. So to actually explain what we're doing here, and so this is, again, I'm a Postgres guy, so I'm going to give you primarily Postgres examples, but you can do analogs to this in other databases. So, like here we have what I consider an acceptably, reasonably secure setup for a reasonable web application. And I'm not here to run an NSA server. The idea behind this is that you've got a web application that you're doing for a startup. You need to have access to it. You need to be able to continue doing development on it. But at the same time, you need to not make it easy. You need to not have an open door for attackers. And so in this particular example, we're using ident on the local host for the super user only, so that we can run administrative tasks. And then here on the local host for somebody sitting at the console, For anyone other than the super user, you have to have a password. And then this is our web application connection. We determined, okay, you've got to be in the DMZ network. The web app that's connecting has to be connecting just to the web app database, and it has to be a user that is part of the web user's role. And I'll go over roles in a minute. And that's connecting by password access over SSL. And this is assuming that you've decided that Kerberos is too much of a performance burden to use with the web application, which a lot of people do. And then, on the inside, however, you're using Kerberos to authenticate your administrators, who can only connect from the local network. And then anybody who is not one of these connection methods is not allowed to connect to the database, period. So that's a reasonably locked down thing that's actually would be reasonable for a web application that you continue to develop. Yeah?
Do you mean that last line, the reject line, or does it do that?
Yeah, it more or less does that automatically. The error message that you get is a little bit more informative if you have the reject line in there, in case you were a legitimate user who just connected from the wrong network. As opposed to just saying no rule for, this actually tells you connection rejected. But yeah, if you don't have that in pghp.conf, then it just doesn't allow you to connect. Now one of the things that we don't have, the reason I'm showing you a MySQL example here is that currently MySQL only supports password and passwordless access. They do support SSL connections, but they don't have the sort of different authentication methods. And MySQL does not have roles yet. So some of this stuff, you can do a lesser degree of this, at least in terms of determining network and user in MySQL terms. And SSL connections, of course. So our third tool here is roles and privileges. And the idea behind roles and privileges is that assuming that somebody has already connected to the database, either legitimately or illegitimately, you want to carefully define in a granular fashion which data they are allowed access to and how. That is, you can say, okay, a regular user can actually read the data in the users table so the web app can display it, but they can't modify the data. That can only be done by administrative users, for example. Now, in Postgres and other other databases with a lot of SQL features, like the proprietary database, Oracle, etc., SQL Server is particularly good for this also. We have full support for what's called the role system. And all the role system is a nested set of, think of it as a nested set of groups and users where groups can belong to other groups. Actually in the role system there is no clear distinction between users and groups. Everything's a role. It's just a question of whether the role can have other members or not. And if you're using a database that supports roles, I strongly suggest that rather than just assigning a couple of different generic users, that you actually create roles and think about what those roles have, and then create users under those roles, particularly for users who are going to be individually authenticated. So like in this case, for example, for admins, we have the admins each has an administrative ID. For the data entry people, they each have their own ID. The data entry people are a sub-role of users. The read-only user, which is guest, is also a sub-role of users, and that's a generic role. And for each of these roles, you can define granular privileges in terms of what the role can do with your different data objects, which get at the highest level from just connecting to a particular database to being able to create objects, use temp space, the ability to execute functions, store procedures and the like, the ability to use and create schema and create objects and schemas, and then for tables, select, insert, update, delete, and of course, if you're going to administrative rights, your ability to modify the table definition itself. And the idea is that you should think about the various roles that people need to connect and assign privileges on a least needed privilege basis. A good example of that, so here we've got using roles and privileges as an example. And so for this, you would have, for example, the admin role, which would have several members that have the right to actually modify anything. Now, in this case, I'm using schema, which, if you're looking at an application in security, can often be a good way to separate your security resources, to say, hey, This is the admin schema, and every object inside it should be highly restricted. And this is the member schema, and every object inside it should be restricted to authenticated users. And this is the sort of general schema, in this case the CMS, which is effectively public. And this makes it very clear that when you put a table into the admin schema, that you should be locking it down. If you're using MySQL, you can use databases for the same purpose. So the admins have the right to modify anything in any schema, whereas the generic web user's role would only have read-only rights to the public schema. And members would also have modification and read-only rights to some of the other schemas. Now, this can get really complicated if you have a lot of database objects, so I pretty strongly recommend using some tools to help you define roles and privileges, because if you're doing it all in the SQL command line, it can get really hard to manage. This is the Postgres Privilege Manager as part of pgadmin. There's a similar tool for MySQL in the MySQL Enterprise Monitor or something. You know, in order to manage all that stuff, I think there's also some independent proprietary tools that do this. So, next tool, database abstraction. And this is one that people generally don't think of in terms of security, but I've used it for excellent effect. The idea is that if you're using an advanced database that supports SQL level abstraction, and what we're talking about here specifically is views and stored procedures, then one of the ways that you can secure your data, one of the ways you can control access to your data and, if properly implemented, secure it, is by allowing normal users access to an abstraction layer, but not to the underlying data. And your two primary tools there are views. For those of you who haven't used them a lot, a view is sort of like a stored query that's saved in the database server and looks to the average user like it were a table. And stored procedures are obviously little programs that you can execute on the computer. If you execute on the database server, if you have sort of full stored procedure support, many stored procedures will actually return row sets, which can then make the stored procedure appear like it was a table. And particularly one of the good things that you could do there is do what are called security definer stored procedures. And this is something we discovered. It's supported in Postgres, not on MySQL. Maybe they will fix it on MySQL, but right now it's not supported. And the idea behind the security definer procedure is that you can get temporary privilege escalation in order to get access to data that you don't have direct access to. So let me show you how that works in terms of actually locking down your data. So one of the things that I showed you earlier when I showed you this model here is that in the model where we're not using database abstraction, we have to give the member, and this will be like your web app user, so your web app connection, read-only access to the users table. The problem with that is that you can actually do a fair amount even with read-only access to the user table by finding other users' information and then using it to escalate your privileges in the application. And that's not something that we want you to do. So what you can do with abstraction is you can say, hey, we're not even going to allow read-only access to the full user table. For example, you can hide the password column. So the first thing you do is you say, okay, the web app does not have access to the admin schema at all. It's not allowed to read anything from the admin schema. It's not allowed to log into it. It's not allowed to even see. Well, it can see that the schema is there. It's not allowed to see what's in the schema. So instead, when the member issues a query against the user information, they get a view called users in the member schema, and that view is like the users table but without the password column. So they can't get the password column by saying, and here, this is, the abstraction particularly is a nearly foolproof protection against SQL injection. Because without access to the underlying data objects, it's very hard for SQL injection queries to succeed. Yes?
So in that model, how would you handle authentication? Like, would you need read access to the password column?
So that's what I was about to go over. So it's a good question. And this is why you need the security definer functions. Because what you do is that when the member needs to log in or change their passwords, they need access to the password column, they access the security definer function, a login thing or a change password function. And that function, and only that function, which is obviously preloaded in the database, gets access, temporarily elevates their privileges so that it can read or write to the password column. But if the member is trying to pass in wrong parameters to one of these functions, then they just get an error message. So they don't have the ability to make the function do something improper, provided that you've written the function correctly in the first place. And that's the basic approach. It requires security definer, proper security definer function approach. Now, one of the things about security definer functions that I have to warn you about is a security definer function, for those of you who are familiar with, like, say, the Unix command line, it's just like a set UID program. If properly used, it can be part of locking down your system. If improperly used, you've just created a new exploit. So you have to look very carefully at the code. In the case of Postgres, In the case of Postgres, you actually have to do certain specific statements in order to lock up the security definer function from things like hijacking. And you just have to really look at, is there some way that the user could put in proper parameters but hijack this anyway? So any security definer function that you do write for security purposes should be subject to a fairly large amount of unit testing that not only tests that the function works, but also tests that it can't be perverted. As well as look in your database system for what the documentation is about locking these things down. So this is part of, and the reason that actually I've got this example up is that this is exactly what I put into a few web applications that are currently online, is using this approach. And it's worked fairly well for them. So, remaining, we have two more tools, and we got a little bit more time. So, one of the tools here, which is really important, and this is the one tool I'm going to go over that's not a control system, which is to say, sometimes your control systems and security measures fail because something happens that you didn't think of and didn't test for. I mean, actually, I will say that if you have an application that has worthwhile data that is in production for a long time, eventually your security measures will fail. Because something will happen you didn't think of. When you weren't there, somebody will turn off some of the security measures. That's one I always like. And it had happened to me any number of times. Things will happen that you didn't think of. Often it's very difficult, if you're a consultant, it's very difficult to your client to take the idea of illegitimate staff access seriously. So even though you give them a program of how to lock down the data from the staff, through using roles and privileges and data abstraction, they don't actually implement it. Give everybody administrative access, for example. And then sometimes there's exploits within your database system or your authentication system itself that allow people to hijack and get into things. So at some point, if your data system is in production, your database application is in production long enough, people will break into it. So what the other question you have to think about in a security context is, okay, what happens after someone breaks in? And that is where auditing comes in. To say, what happened, when did it happen, how did it happen, and what did they get? Because as bad as it would be to need to mail 36,000 users that their data was stolen, it's even worse to have to mail all of your users that their data might have been stolen, but you don't know if it was. Because the first one is just bad, and the second one is both bad and makes you look incredibly incompetent. So there's two main tools that you use for data auditing. One is data logs. That is, most database systems come with a way to log queries coming into the database. Now, this can actually be a significant performance burden, but if you're concerned about security, in my opinion, it's worth it, and there's ways to ameliorate that. So in the case of Postgres, this is the activity log. In the case of MySQL, it's the query log. You add various options for, in the case of Postgres, you have a lot of options for what you want to log. In the case of MySQL, it's just either on or off. And you can log all the queries being run, connections. I've actually found from a security context, simply logging the connections and disconnections, it often provides you with extremely useful information about who is in the system and when. And also, don't forget to look at your error messages in the log, because often an illegitimate user will generate a lot of errors because they're trying to figure out where the data in the system is. And automated looking for certain error messages can often alert you that an attacker is in the system real time. So the other issue with logs that you have to think about is, and that's a little bit more difficult, is that the logs themselves have to be locked down. And one of your problems is that because one of the things you're specifically trying to deal with logs is illegitimate employee access, simply having them in a directory with root permissions on the database server isn't really adequate, because there's a good chance that the staff member has access to those. And if they can modify the logs, then your logs haven't given you any information that they didn't want you to have. So I highly recommend using a secured log server. Linux and BSD, syslog. Okay, a lot of systems, Unix systems, syslog makes this relatively easy. You can have an authenticated server. You can have all the syslog messages automatically go to the separate secure server. If that's not an option for you, then you might want to look at a plan for copying the logs on a regular and frequent basis onto a secure server. This would be an example Postgres. I'm actually running short on time, so I'm going to zip through this. An example Postgres configuration. With MySQL, you just go ahead and start the query log. Right now, MySQL has no automated built-in way that I know of to log to an external server. But I've been given to understand that MySQL proxy or the enterprise monitor may be hackable to actually achieve this. So your second method here is what I call data auditing. And data auditing is, again, using the inside the database tools, particularly triggers. And the idea behind this, and I've implemented this again on any number of systems, I started writing it up for my blog, I will finish it eventually, which is that you have, say, for every schema that you have in your database, you have a ghost schema that is an audit schema. And that's, again, been secured so that, as much as possible, regular authenticated users, not administrative users, can't even see that schema. And then you have a trigger on each table in the regular schema. So every time you have any data modification going on in the regular schema, you have a copy of the old data being written to the ghost audit schema. And this is a way to log all database changes without imposing a performance burden on your in-production tables. Because ideally, you're only going to be looking at this log the one time a year that you think somebody broke into your system, and not most of the time. So that table-wise, that would look like this. If you've got members' profiles here, then the audit thing simply has a timestamp and a user that is added to the primary key so that you can have multiple rows for every row that is in the production table. And this sort of thing is actually extremely useful. I mean, this is the one where I told you, I can give you an example from my real consulting, which was for one of my clients, a media company. They fired somebody with some acrimony between the management and the employer, and they forgot to cancel their login on their web-based news system. And so the employee, who was both smart and bore an enormous grudge against this company, logged in the next day and changed a whole bunch of news items, but often in very subtle ways. And then they also deleted a bunch of information. And the client called me up and they're like, oh my God, this happened. Can't believe I was so stupid. How are you going to be able to restore this? We need to get the backup tapes. And I'm like, well, actually, we don't. It's not really a problem. Hold on, let me run a few queries. Because since that person was coming with regular user access, not only did they not have any ability to modify the audit information, they also, in this particular case, weren't even aware that it was there. So I was able to, just by query, roll back any changes made by that particular user and restore the data from the last change that the user had made within about an hour. And that actually secured the goodwill of that particular client for going on 5 years now. Here's an example of an audit, a very simple audit trigger written in PLPG SQL. You can do it in whatever sort of language that supports triggers, and PSM and MySQL and Perl or anything and that sort of thing. It gets a little bit more complex when you have sort of dependent child tables or tree structures in your database, but all of those things can be audited. So in the 60 seconds or so that I've left, I just want to mention, if you in fact have an application that has data that needs to be highly secure, like for example, you are running in the healthcare field or in the legal field, where even without getting broken into, if your data is considered not secure enough by an external examiner, you can be sued or shut down. Then you might want to look at taking your data security to the next level. And a lot of people have been looking at this issue lately, particularly in the sort of NSA, security advisory government thing. And so one of the things they came up with a while ago was something called SC Linux, which is a particularly locked down version of Linux with system-wide role-based access control to Linux. Solaris has this thing called Trusted Solaris. It's actually fairly similar, although not exactly the same. And then what a team in Japan, where they used Postgres heavily in production, both in banks and the government, did, was that they created this thing called SE Postgres. And what SE Postgres does is it integrates your data security directly into the network-wide, highly locked-down security of SE Linux. The idea being that all of that authentication and connection and data access down to the row and column level should be determined by network-wide policies. These are diagrams, giving you an idea that if you have, in a lot of cases, and this actually gets even down to data hiding, where in regular SQL security, if you're not allowed access to information, you just get an error message or get a blank or a null or whatever. In the case of SE PostgreSQL, often you're not even aware that the data exists. It's hidden from you. I will say that this is very complex to set up and administrate and is pretty much almost entirely incompatible with ongoing application development. So it's something you only want to do if your security needs are very high and your development productivity needs are not that high. But it can be useful for doing some super lockdown. So that's how to make your data happy and safe. It's my contact information on SE Postgres and that sort of thing in terms of getting information for stuff. I will be giving them my slides in the speaker lounge, so hopefully they will be up on the O'Reilly site. Of course, some of you may have heard that I recently left Sun Microsystems, so you can ask me questions or about security or make job offers after the talk. Thank you.